Hi, this instructional video is about dividing polynomials. It's a continuation from the last one where we used synthetic division. I wasn't so happy with the last one because we didn't end up with a perfect remainder 0, which would have been the factor theorem. So let's try this. Let's try another set here. Here we have x cubed minus 7x plus 6 divided by the binomial x minus 2. Now look at this polynomial carefully. There's something missing here. We have x cubed, we have x to the first degree, but not the second one. We talked about this. We need a placeholder. Okay? So first, let's identify the coefficients. We got 1. We don't have an x squared, so we're going to put a 0. And then the x is going to be negative 7. And then finally the constant 6. And then we're going to divide that using the synthetic division and divide it by a k. But the k is the inverse of the term from a binomial, which is going to be 2. So 2 goes over here. So here we go. Bring down the leading coefficient 1 to get things started. So the k2 times the 1 is 2. 0 and 2 combined gives you 2. And 2 times the 2 here is 4. And the coefficient negative 7 and combine that with the 4 gives you negative 3. And finally the k, the 2 times negative 3 is negative 6. Oh ho! And the last constant 6 combined with this multiple negative 6 is a 0. Yeah! So what is the factor according to the factor theorem? The quotient between this polynomial and this binomial? Well, that was a mouthful, huh? It is actually 1x squared plus 2x minus 3. Yeah. Now, how do you prove that's correct? Well, let's just multiply this quotient with this binomial. Like this. X minus 2 times x squared plus 2x minus 3. Distributive property, remember, 1, 2, and 3 that way. So that's x third plus 2x squared times negative 3x. Now the second term of the first binomial says, me too! So negative 2 times x squared is negative 2x squared. Negative 2 times positive 2x is negative 4x. And then negative 2 times the last term, negative 3, is positive 6. We combine the middle terms. So we got 2x squared, negative 2x squared. That cancels out. And we got negative 3x, negative 4x becomes negative 7x plus the 6 and the x third. There it is. See? So this is the proper factor. So now, that being said, you tried that one. Okay. So you said, I got it now. I have to make sure that the polynomial is in a proper sequential degree. x4, x3, x2. Hey, there's an x missing. So we need a placeholder for 0x. So here we go. First coefficient is 10, 5, 4. It's missing the x term, so we put a 0, and then the constant negative 9. And we're going to divide those by the k, which is the constant term from the binomial factor, and it's the inverse, so it's negative 1. So we're going to divide the whole thing by negative 1. Oh boy, I'm not getting a good feeling on this one. Let's see. Bring down the 10. So negative 1 times 10 is negative 10. 5 and negative 10 combined gives you negative 5. So negative 1 times negative 5 is positive 5. The coefficient 4 and 5 combined become 9. So the k, negative 1 times 9 is negative 9. 0 and negative 9 combined gives you negative 9. Hey, look at this. Negative 1, the k, times a negative 9 gives you positive 9. Remainder is 0. Whoa. The factor theorem prevails. So what is the factor, the quotient, between the polynomial and the factor x plus 1? It is 1 degree less, so it's 10x cubed minus 5x squared plus 9x minus 9. There it is. Doesn't it feel good when things work out?